Here's some help on a couple of problems on your review sheet for Chapter 6 and a little bit of review from Chapter 4 and 5. This is number 13 from Section 6.3, and we want to be able to find the sum of a geometric series. So a few of the terms, 3 of the terms in fact, of the 7 total terms in this series are given. And we're going to use this formula. Anytime you are asked to find the sum of a geometric series of a certain number of terms, meaning it'll be a finite series, this is the formula that you're going to use. So n stands for the number of terms in the series. In this problem that will be 7. A sub 1 stands for the first term of the series. In this case that will be 5. R stands for the ratio. What is that number that we're multiplying by each time to get from one term to the next? And if that's a little troublesome for you in determining, you can always do some little simple math here. If you want to find out what R is, just couple maybe the first 2 terms of the series and always do this order. Within this set of red parentheses that I've drawn, you always want to do the second term divided by the previous, or the term in front of it. So if you want to know what R is, do this little division. R means ratio, and that's what we've made here. We made a ratio of the second term in this couple divided by the one in front of it, so that means R has to be -2. And if you want good assurance that you've done the right thing, maybe do that again. Just slide down by one term and put the next 2 in a group. So here I have -10 and +20 in my blue parentheses, and doing this same little easy division problem, take the second of those 2 numbers, 20, and divide by the one in front of it, which is -10. And that's what the common ratio means. If we do this little division exercise all the way through the series, we should get -2 as a result every time. And you can think of it this way. If it's more obvious, notice how if we do 5 times -2, we get -10. If we do -10 times -2, we get +20. So -2 is known as the common ratio. It is the number that is being used to multiply these terms to get to the next term. Okay. And now that we've identified all of the parts of this formula, these letters, we're ready to plug in, and then we can just turn it over to our calculator. Okay, so once again, this S means the sum of 7 terms. That's what we're told. First term, of course, is 5. We can see that from our given problem. 1 minus R. Remember, we found out what R is. It's -2. Notice I'm putting -2 in parentheses. And now I'm going to raise R to the same number that I put in for N at 7. There's 7 terms. And then in the denominator, I'm going to do 1 minus R again, which R is -2. Okay, so now it's pretty much, once you know the formula and you know how to plug in, your calculator is going to do the heavy work. The sum of these 7 terms, let's just plug into our calculator. You're going to do 5, left parentheses, 1 minus -2, and then you can raise -2 to the 7th power. Close your parentheses at that point, divided by. Now personally, if I were doing this problem on the test, I would just say divided by 3, because that's what 1 minus -2 is. So you certainly could just say divided by 3. If you don't trust yourself to do that mental math and you want to go ahead and plug all of this in, then you need to put all of this in parentheses. Okay, so it should look like this. Now before we hit enter, let me give you a word of caution. Let me give you a heads up on a very common mistake that people make in problems like this. They see minus negative and the reaction that most people have, and I've seen this already this year, the tendency people have is to go ahead and make these become plus. And that is incorrect. You have just violated the order of operations if you do that. Because order of operations says before you can do subtraction, you need to first do powers. And if you change these both to plus, in essence, you have done subtraction before you've done power. So you are out of order, and that's going to throw your answer off. So just a word of advice, please keep in mind that in cases like this, you do not change these to plus. Just enter it into your calculator just like I've shown, and I'll give you a second. Hopefully you've already had a chance to do that, and your calculator should show that the sum of those 7 terms in this particular series will be 215. Okay, so know the formula, know how to plug into replace the certain letters of the formula, and then obviously know how to use your calculator correctly, parentheses where needed, and then avoid this common mistake, subtracting a negative. Okay, so that takes care of number 13, and then let's try number 28. On number 28, what we're after here is making sure that you understand those 3 properties of logarithms: the product property, the quotient property, and the power property. All 3 of them are going to be needed to take these 3 separate logs and combine them into a single logarithm. Okay, so the first one I'm going to use, in order to combine multiple logs into a single, you can think of it this way. These numbers that are being currently used to multiply, like 2, 3, and 5, they need to be moved. I sometimes refer to this as clearing out the space in front of the logarithms so that we can combine them. So this 2, according to the power property, can be moved so that it becomes an exponent for 6. This 3 can become an exponent for 4, and this 5 can become an exponent for 1/3. And all of that can be done without changing the problem. It's still an equivalent expression. It's allowable because of the power property. So here we go. I'm going to write maybe more than I need, but I just want to make sure you're following. So this is going to become natural log 6 to the second plus natural log 4 to the third minus natural log 1/3 to the fifth. Okay, and I think now I'm going to just go ahead and simplify these. Instead of showing them as exponents, I'm going to call this natural log 36, and this is natural log 64, and this is natural log. I've noticed fractions sometimes gives people a little bit of trouble, but if you understand what 3 to the fifth is, 3 to the fifth is 243. 1 over 3 to the fifth, now you're just multiplying 1/3 times itself 5 times, and that's just 1 over 243. Okay, so we've looked at the power property. Now let's just go left to right, and I would suggest very strongly that you just take these 2 at a time. Don't get into any rush. Sometimes people make mistakes trying to do more than one step at a time. I would just take these 2 at a time. Let's combine these first 2 as we move to from left to right, and they're being added. So the product property says that 2 logs, as long as they have the same base, that are being added can be joined together as one single log using multiplication of the numbers. Okay, so once again, maybe I'm writing more than you need, but I just want to make sure that you're following. So one single log of the product of 36 times 64. Okay, and so let's grab our calculator, and we'll see what that is. 36 times 64, and that's 2,304. Okay, so this is going to become natural log 2,304, and I'll just bring down this other log. Now we're ready to combine these two separate log expressions into a single. They're being subtracted. But we have a quotient property that says two logs that are being subtracted can be joined together using one single log and division of the numbers. Okay, so the left number goes on top, and we'll be dividing by 1 over 243. Well, we have to be careful here. We got to remember that old rule that says dividing by a fraction means to multiply by the inverse of that fraction. So I'm going to be essentially doing natural log 2304 times the reciprocal of 1 over 243, which is 243. And once again, we'll grab our calculator and we'll be ready to come up with our final answer. So 2304 times 243, and that equals 559,872. And that ends up being our final answer. We have taken the original problem that had three different logs being added, subtracted, and we've condensed it down into one single logarithm using our properties. So just want to make sure you understand those three properties and know how to use them. And that is the help on these two problems. And if you have any other questions, let me know.